So, taking a look at the mod f cougar path, the one thing that is really true about this, unequivocally true, is that if you can factor, you will have much more success than if you forget how to factor. Now, if you look back, we did have some factoring practice in prior cougar paths from semester 1. So it might help you to look back. I forget which module it was. Let me take a look here in my notebook. Cougar Path C. So I do have some videos up about that hopefully will help you to factor. It's not going to be my big focus here to show you how to factor. My big focus is going to show you how to use factoring to solve these problems. Okay, so let's take a look at problems 1 and 2. They say to simplify each and state the excluded values. Well, why would any values be excluded? There's one thing that you can't do in math, ever, no matter who you are, and that is divide by 0. So any number that would at any point make the denominator 0 is off limits, it's excluded, it's a no-go, no matter what. So I'm going to factor the top, I'm going to factor the bottom, I'm going to cancel whatever is the exact same on the top and the bottom, and I'll show you kind of what I mean by that, and then I'm going to find my excluded values. So the top, the numerator, is going to factor into x plus 3 times x plus 3, and the bottom is going to factor into x minus 8 times x plus 3. And like I said, you got to be good at factoring here, okay? So top to bottom, x plus 3 and x plus 3 are going to cancel. Now, some people, they feel inclined, I think before this happens, I don't know why, they feel inclined to cross this out. That's not good. And I like to joke in my class, if you cross out like that, if you cancel like that, puppies die. That's not the way it works. Please don't do that. What we're looking for is things that are being multiplied to cancel, not things that are being added. So that means that I can't just cancel this x with this x. That's not how it works. It's got to be the whole thing or nothing. But so x plus 3 and x plus 3 are going to cancel each other. It's going to leave us with x plus 3 on the top and x minus 8 on the bottom. That's the simplified version, but we still need the excluded values. So what I'm going to do, it's kind of like the zero product property. I'm going to think about what values of x would make these 0. And then I'm going to write that x can't equal them. So x can't equal 8 because if I plugged in 8 right here, it would make the denominator 0. And if I plugged in -3 into the second binomial there, it would make my denominator 0. So this is my full incomplete answer right here, is that the simplified version is x plus 3 over x minus 8, with x not being able to equal 8 or -3. We can take a look at our second one. Hopefully, you'll notice that this bottom piece, we're only going to be able to factor out a GCF. We are not going to be able to factor this into binomials. So my GCF of the denominator is 9. And if I factored out that 9, I would end up with n plus 3. So let's hope that we end up with an n plus 3 in the numerator, and things will be good. So it's going to be n plus 6 times n plus 3. And all of these have an a that's 1, so they're really easy to factor once you get comfortable with it, and I really do strongly recommend that you get comfortable with it. So n plus 3 is going to factor once again, leaving us with n plus 6 over 9. Now, with just 9 as a denominator, like 9 or -9 is not going to make that 0. So 9 is not invited to this exclusion party, okay? Which, is there such a thing as an exclusion party? Probably not. But this n is, if the n was -3, it would make the whole denominator 0. That's the only value that n cannot be, and we're good.